In this video, we are continuing looking at the problems in Chapter 18 from the study guide for the upcoming test for the AP students. Okay, so this is in Chapter 18, and this is question number 29, and it deals with dice and dollars. Okay, so this is one roll of the die. You can see these are the outcomes of the die, and then this is our random variable, which is the payout. So according to the problem, we win nothing if the number of spots, in other words, the number on the die is odd. So that's here, here, and here. X would equal 0. And then we get $1 if it's 2, $1 if it's 4, and $10 if it's 6. So this is the sample space for my random variable X, and these, of course, are the probabilities. It's a uniform distribution because it's a fair die. So part A asks us to find the expected value and standard deviation. Expected value is, since all the probabilities are the same, it's just basically a simple average of all of these. But of course we can multiply one by one, 0 times a 6, 1 times a 6, etc. If we add these together, it's just the same as a normal average. And we would wind up with 12 over 6, which is 2. So the expected value for our random variable is 2, so that's $2. And standard deviation. So standard deviation of X is, let's see, for this one, we're going to have to, now I know I worked this out. Oh yeah, here we go. Okay, so we're going to have standard deviation square root of the variance. Variance is what we get when we take our $2, subtract it in turn from each of these, right, and then get a square and then multiply by the probability. So you know that formula, or you can look it up. But basically we wind up with 6 terms. None of them come out to 0. First we get 2/3, then we get a 1/6, then we get another 2/3, and of course another 6, because we're repeating ourselves here in the distribution. And another 2/3, and finally we have something different for this one, and that's going to be 10 2/3. So you add these up, and you take the square root of the whole thing, and you wind up with approximately 3.61. And that's actually the square root of an even 13. So we can say the variance, in other words, when we added this up before we took a square root, we had 13. So the variance of our random variable is 13. I think that's important in one of the other sections. But that answers section part A of question 29. Part B, you play twice, find the mean and the standard deviation of your total winnings. Okay, well that would be, now we can't just say 2x, right? We have to keep them separate. So let's say x sub 1 is the first time we play, x sub 2 is the second time we play. Now of course expected values add, so this is just going to be 2 plus 2. So we expect to win $4, of course, from playing twice. And the standard deviation, now here's where variance is going to be important. The standard deviation, we can't just add them separately. We can't say that this is equal to this separate standard deviations. We can't say this is standard deviation of x sub 1 plus standard deviation of x sub 2. We can't do that. But what we can do is say, hold on, we can say that the variances add, right? Variances definitely add, so I'll write variance. Okay, so if the variances add, that means that we want to use the 13, right? The variance of our random variable is 13. So this would be 13 plus 13. So the variance of the sum of the variables is 26, right? And so now we just have to take a square root of 26. Did I do that? Somewhere. Okay, yeah. So I think what I got when I took the square root of 26, I got 5.099. I'm sure the book rounds it up in the back, but that's what it is. Okay, that's B. All right, so C. You play 40 times. What's the probability that you win at least $100? So, okay, so we play 40 times. So let's see. Okay, so this is going to involve two things. One, it's going to involve eventually me using this picture. But first of all, we're going to have to calculate expected value. And since this is 40 attempts, you can see this symbolizes that like I'm thinking about all 40 of them as separate instances and therefore separate random variables. So what will this equal? Okay, well, since they're all, every one of them is, what did we say, $2? Yeah, we expect $2 on every single one of them. So really this does just come down to 40 times 2, even though our random variable is not 40x. We don't write that, but we can certainly say that there are 40 of them, so yes, we can multiply. So our expected value of the whole thing is 80. And then, in order to get our standard deviation, we of course have the variance of all those x's, the same thing I wrote up here, all those x's, is equal to 40 times, what was it, 13 was the variance of one of them. So that gives me, what is that, for 520? And then I got to take the square root of that, and so the standard deviation will be 22.8, and really it rounds to 0.80 for the hundreds place. Okay, so now they're asking us, what's the probability we win at least $100? We got to go down here, and we need to put down our center, which is, okay, so this now, the center is 80, right? Because now we're making the graph of this random variable, which is the combination of all this. Expected value in the center is the 80, and then the standard deviation is 22.80. So right here already, we have 102.8. Okay, so we want at least $100. So we want to be right here. Let's say that's not great, but let's just, there we go. So let's say that's 100 right there. Okay, so what is this z-score? That's what we want to know. So in this case, z equals, so we'd take 100, like always, we're doing our x value here, subtracting 80, which is the center, so of course we're going to get 20. This value is 20 away from the center, and we're dividing it by the standard deviation. And what is that? Let's see. We wind up with, well, hold on. I think I need to pause. All right, so we divide, we get 0.877 for our z-score. We look it up, we get the area under the curve from negative infinity all the way up to here is 0.8106, which means 1 minus that gives me the rest of this. So 1 minus that gives me the area over here, which is 0.1894. And that, friends, is the probability that we get at least $100, because this is the $100 right here. Okay, we're moving on to 35. We've got carbon monoxide emissions varying. Mean is 2.9. I wrote that in the middle. Standard deviation is 0.4. This is grams per mile. So since the standard deviation is 0.4, I added that to get this, subtracted to get this, so this is all set up. N equals 80 here because we've got 80 cars in the fleet, and Y bar represents the mean level for the company's fleet. So this is not a proportion, this is a Y bar. Okay, and it says, what's the approximate model for the distribution of Y bar? Well, it's going to be this. It's going to be approximately normal, because this is an example of the central limit theorem here, because that's what happens. No matter what the distribution of the actual pollution for that particular car, you know, as it varies from car to car within that make and model, It might have any type of distribution, it might have a skew, but not the sample mean. The sample mean as a random variable will look like this by the central limit theorem. Okay, and for part B, estimate the probability that it's between 3 and 3.1. So that's why I put these right here. This is your 3, and maybe I'll move this one over. This is supposed to be your 3.1 here. No? Not going to let me? Creeping over there. Okay. So this is your 3 and this is your 3.1. So they're asking, what's the probability that we are between these two values? So we want this area, this slice right here. Okay, well, in that case, we need two areas, really. We need the area up to here, and then we need the area up to there, and then we need to subtract to get the area in between. Okay, so what are these two areas? So we get z-scores. Z here is 0.5, and z here is 0.25. In other words, 3.1 minus 2.9 divided by 0.4. It gives us an exact 0.5. This gives us an exact 0.25. So those are nice, easy z-scores, and I look them up, and I get that this area all the way up to here is 0.6915 from my table, and this one is 0.5987. So getting the area between is just a matter of subtracting these, and I get 0.0928, and that's the area in between, and it's also the probability that our sample mean falls between 3 right here and 3.1 right here. Okay, so that was part B. All right. This is C, there is only a 5% chance that the fleet's mean carbon monoxide level, did I say? Yeah, carbon monoxide level is greater than what value? There is only a 5% chance that the fleet's mean carbon monoxide level is greater than what value? So in other words, we need to go out to where 5% lies beyond, and I don't know if I put that in the right place, maybe not. Maybe it needs to be a little closer to the center. Hold on. No? You don't want to do that for me? There we go. So let's say this is 5%. I don't know if it is now. Let's say that's 5%. We want to know if this is 5%, basically, what is this value? So in other words, we want to know what area of, the area of 0.95 is corresponding to what z-score on the table, and then that z-score on the table lands us where in terms of this particular mean and standard deviation. So this, if you look this up on the table, 0.95, you find, what do you find? Oh, it's 1.65, right, which is our critical value for a 90% confidence level. That makes sense because, for a 90% confidence level, we'd have 5% over here and 5% over there, and you'd have 90% in the middle. So this is what we would expect. Okay, so this is our z-score. Now, they're asking, what is this? Well, this is not 1.65. This is 1.65 standard deviations away from the mean, or you should say greater than the mean, right? So that means that we take our mean, 2.9, and we add onto it this many standard deviations. So this much, the critical value, times the standard deviation. So this right here will give us 3.56. So this is 3.56 grams per mile. So that is the value that we have for 3.56 grams per mile. We have only a 5% chance that the actual carbon monoxide level of the fleet is greater than that. Okay, we're pausing. Okay, so number 41, this one might take a little while. We've got 4 parts here, and we have 2 different universities to think about. So the first question is the most straightforward. They're asking us about East State University. It's got a mean of 130, standard deviation of 8. So we can set that up. and take away. Okay, so we select one student at random from each side. Probability of the student's IQ is at least 125 points. So you can look up the answer in the back, and I've done lots of examples like this, but hold on. 125 is about here, right? So we could find the z-score, and then we can find, we're asking the question of at least, so we want to know, all this. Okay, so it's the same kind of problem that we've been doing. So let me focus then instead on the next question. Part B, hold on. Part B is we select one student at random from each school and find the probability that the East State student's IQ is at least 5 points higher than the West State student's IQ. So now we have, we could say variable difference. Hold on. No. Okay. Variable difference equals the East Side student minus the West Side student. Okay, so this is a random variable. The difference is a random variable, and it's made up of the other two are random variables, and we're finding the difference between those. Right, I can use both here. Okay. All right, so we want to know the probability that this difference is at least positive 5. Okay, so we're going to have to use this again, but when we use it, we're going to have to use the mean and the standard deviation of this. We got to figure out what that is. Okay, so we need expected value of D, which is going to equal the expected value of the difference, which, because of the way expected values work, because of the way expected values work, this is just going to be expected value of the first one minus expected value of the second one. So that's 130 minus 120, so this is just going to be 10. So our center here then is 10. The center of my distribution is 10. All right. Standard deviation, well, we know that variances add, so we can say this is going to be the variance of D is going to equal, now here's the thing, we might expect, hold on, we might expect to just take these variances and subtract them. We might expect to do this. I know that's messy. Kind of debating how I should do this, with a mouse or with my homemade stylus. Well, that's awful. Okay, hang on a second. Okay, experimenting with different methods here. All right, so this is what we might expect. We might expect, okay, well, if the expected value of the difference equals just the difference of the expected values, maybe the variance works the same way. Well, the thing is, you got to remember, variances add, they don't subtract. So in other words, even if we're subtracting our random variables, the variance of the difference will equal the sum of the individual variances. You can look that up in your book. This is always addition. Okay. Now, what that means is we go ahead and we've got, for East State University, we got standard deviation of 8 points. So that means we need the square of 8, and we got to add it to standard deviation of West State, which is 10. So we got to add this to the square of 10, so we get 164. So if we want standard deviation, now we're taking the square root of 164, and it's approximately, what is it approximately? I don't remember what I got. Oh yeah, okay, so it's approximately 12.8. Okay, so that means as I walk out here to the next goalpost, I've got 22.8, and as I walk back from 10, now here's the interesting thing. Look what I do. I subtract my 12.8, and I get a negative value. Now that might surprise you until you really think about it. Think about what this variable is that we're charting out. We're charting out the difference. Suppose that for a particular sample, we got west side with a greater average than east side. Well, then the difference here, the difference up here, x sub e minus x sub w would actually end up being negative. So this makes sense. This seems like something that could actually happen. We might actually have that type of outcome. All right, but we want the probability that this difference is at least 5. So we're talking about something that's like about there, or actually closer to like maybe there. Yeah, that's much better. Okay, so once again, the trick here was really the setup. After this, it's the same old problem. We're getting a z-score. We're finding area up to here, and then we're doing 1 minus that area. So we wind up with a z-score of, I think, negative 0.39. We wind up with area over here of 0.3483, which means that this is an at least problem, so we're interested in the area on the right, which means we're doing 1 minus 0.3483. So we're getting 0.6517. Okay, that's part B. Part C, 3 West State students at random. Find the probability that this group's average IQ is at least 125 points. Now your first tendency might be to say, okay, I've got 3 students, so I need to have 1, 2, 3 random variables, and I'm adding them up. Okay, and finding the expected value of that. But let me read this thing again. Part C is, we select 3 West State students at random, find the probability that this group's average IQ, in other words, the average of these 3 people, is at least 125 points. So we're not talking about the expected value of the sum of the 3, right? We're talking about the expected value of the average of 3 people. Basically, we're talking about a sample mean, right? Expected value of y bar is what we're talking about. Well, the expected value of y bar is always going to be the average of the actual distribution. In other words, the actual distribution of y, or x, well, maybe I should say x bar, since I've been calling this x all along. I should say expected value of x bar, maybe even sub w, right? Okay, so expected value of that. Well, that, of course, is going to be 120, because it says in the problem, right? Suppose the IQs of students from West State University can be described by a normal model with mean 120. Well, that means that what we expect any sample, right, any size sample, to have an average of 120. That's what that means. Okay, this right here, though, we can say, all right, well, standard deviation is not going to be the same as just the distribution of x sub w. X sub w, it says in the problem, has a standard deviation of 10, that distribution, right? Well, when we take a sample mean and we're talking about the distribution of the sample means, well, the bigger the samples that we take, the less the standard deviation is going to be, right? The tighter it's going to be around this 120, right? And we have to do, and I shouldn't write, here's what I should do. I should say our standard deviation, right, for x bar, oh my goodness, for x bar sub w, hold on, is equal to the population standard deviation, as far as we know it, over the square root of n. In other words, however big my sample is, right, however big my n is, that is going to have a big effect on how spread out my sampling distribution is, right? So in this case, standard deviation of the population is 10, and we are taking a sample of only 3 people, right? So I have 10 over root 3, and that is approximately 5.77. Okay.
Hold on. Okay, now finally part D. Almost there for chapter 18 anyway. It says, we also select 3 East State students at random. What's the probability their average IQ is at least 5 points higher than the average for the 3 West Staters? Well, this is a lot to think about, but let's just take it a step at a time. We already found the expected value and the standard deviation for our sample mean of 3 West Staters. We've got to do the same for the East Staters. Now we're doing this. Expected value of our sample mean for the East Staters, of course, is going to be 130. And our standard deviation for our sample mean of the East Staters is going to equal their standard deviation over root n, which is, what did they say, 8 over root 3, right? And what is that? That is approximately 4.6188. Okay, so we got all this information here about x sub w bar, and we got all this information about x sub e bar. Basically, we know mean and standard deviation for the 3 guys from West, or the 3 people from West, and the 3 people from East. And they're asking about, basically, they're asking a probability question about yet another random variable. We now want to consider the random variable that is created when we take these guys and their average IQ and subtract these guys and their average IQ. Well, this might be a lot to think about, but it actually, when you look at what's involved, it's not that complicated. All we got to do is make another random variable, and we'll just call it D again, because I don't really care. And that will be this average minus this average, right? So now we just got to find, and I'll just partition this off here. We just got to find expected value and standard deviation for this. That's all we got to do, right? So the expected value of D, since D is the difference between these two, would just be the difference between these expected values. 130 minus 120. Yet again, we have 10 for the expected value of the difference. What about the variance, or what about the standard deviation? Okay, so we need to do variance again. This is going to be variance of x bar sub w plus, right, not minus, just like before, variance of x bar sub, oh, I should have put e. This should be e. This should be w. Okay, so we're going to add these variances. So we take this standard deviation and square it. We take this standard deviation and square it. What do we wind up with? I think we wind up with things that are like pretty darn exact. I think what we wind up with is basically if we square the East Siders, we get, oh, hold on, this didn't matter because it was addition anyway. And, oh, these are the East Siders, I'm sorry. Now I'm getting mixed up. Anyway, same difference. We just have to square this and square this. So we when we square the East Siders, I think we get 21 1/3 exactly. And when we square the West Siders, when we square this number here, we get 33 1/3 exactly. So basically we're adding those variances. We're getting 54 2/3. It's cutting out a little there. Getting 54 2/3, and then we're taking the square root of that. And we wind up with standard deviation is approximately 7.39. Okay, so just to review, first we found mean and standard deviation of the average of these 3 guys. These 3, I should stop saying guys. I don't know why I'm thinking about guys. But 3 people from the West, West State, okay. And then the average of these 3 people from East State. Okay, so we get these averages and we get the standard deviations, and then we create another random variable by just subtracting these 2 random variables and coming right out of that, an average and a standard deviation. So we don't really need all this stuff anymore. At least, I hope we don't. We'll see. No, I think I finished this problem out and we don't need it. Okay, so now this is the only random variable we care about. So now we're going to use our normal curve and we're going to say put 10 right there in the middle and then space it out according to this standard deviation. So we got 17.39, right? And we've got, what do we have? 2.61. And so on if we want to keep writing. But we don't, because what we want to know is the average, the probability that the average IQ is at least 5 points higher. 5 points higher being about there. We want to know then what is all this. And so we find the area up to here by getting a z-score, which is going to be 5 minus 10 over the standard deviation, which is approximately 0.677. I look it up on my table. I get the area over here, which is 0.7. Wait, that doesn't make sense. Okay, well, hold on a second. Something went wrong. Okay, well, of course, I messed up the sign. This is negative, so this should be negative, which means that this area right here is, okay. This area is 0.2483, and so this that we really want is the complement of that, so my probability is 0.7517. Okay, so that winds it up for the Chapter 18 exercises. I am going to make another video now for the Chapter 19 exercises.